We see complete spin-offs of existing companies starting with 12 machines in it, equipped by us, or companies and entrepreneurs that they get to meet us. They had wanted to had a business idea, producing a chair or like a line of products and e-commerce globally, and they buy as a first manufacturing technology hours, and they start a business from scratch. I've seen that happening in Mexico, in Japan, in the US, in Italy. And this is
Yep.
the thing that makes me the proudest of, because it means that we're creating value.
I'm Nate Wheeler, host of Manufacturing Insiders. Thanks so much for joining us today. So excited to have you. We're going to share some really awesome insights from a manufacturing leader. We only get the best on Manufacturing Insiders, people that have solved real world challenges, and I want you to learn something from them today. We have so much collective experience here, not only from our guests, but also as a marketer. My main company, We Create, generates millions of dollars of revenue for manufacturers every day. And if you would like to talk to me directly about that, I'm happy to give you a free audit. Just reach out to me. But enjoy this episode. Please give us a like. Please give us a subscribe. All those likes, every single one of them helps us grow our channel and helps more manufacturing leaders learn from the information that we're sharing. Thanks so much. Welcome to Manufacturing Insiders. Today I have Francesco Di Stefano with Caracol, and he's from Italy. He's got a wonderful accent. He's got a great personality, and he's going to be very enjoyable to talk to today. But unfortunately, my pronunciation of everything is not perfect. Francesco has built an amazing company, really focused on large format CNC robotic 3D printing, which there's a lot of words in that. So he's going to break down exactly what that all means for us. They just raised $40 million in Series B funding, and they are global. They have representatives in most of the major countries, and they're really helping a lot of smaller companies, machine shops, injection molders, companies like that, turn their businesses into micro factories instead of just sole service offerings. So very interesting stuff. Looking forward to this conversation, Francesco.
Thank you, Nate, for the invitation. It's a pleasure to be here.
Absolutely. So before we get any further into it, just break down exactly what you guys are building, and it just kind of describe to me exactly what that large format CNC robotic 3D printing is.
So basically, when we started, we saw I was for example working in aerospace, automotive. We saw that the manufacturing of large scale parts was still very manual. In some cases, they were requiring a lot of tooling and a lot of different processes that were taking the process to be very long, inefficient, and unsustainable with a lot of waste. My co-founders, Giovanni and Paolo, decided to use the advantages of additive manufacturing, 3D printing, as a potential solution, but they understood that it was very small in scale. So they had the intuition of combining it with robotics, with robotic arms, to make a new technology, what was called at the time large format additive manufacturing. So a way to leverage the advantages of producing on demand with little waste, with complex geometries of additive manufacturing, but at a larger scale, with the freedom of geometrical, freedom of robotics. So it's basically that came to as a core to our business. Today, we offer large format advanced manufacturing solutions through our proprietary hardware and software robotic platforms. We start from additive manufacturing, but our technology can be integrated also with CNC heads. So not only printing, but also finishing the parts, and also with scanning capabilities that would allow, for example, to control the part and have also a more and more automated workflow. As of today, the company started, as you said correctly, in Italy as four friends together, and then launched on the market in the end of 2018, and then scaled significantly, growing 2x every year, raised some rounds along the way, and today we are a global business with two main headquarters, one in the US, in Austin, Texas, actually, where we assemble the USA machines. So we decided to commit locally to the market, and is our fastest growing and more interesting market of expansion, and of course our core market of Europe, with our headquarter in Italy, where we have an R&D center where we develop our new tech, software, and hardware, and of course our production center in Barlassina, close to Milan, where we assemble and deliver all the machines for the rest of the world.
Fascinating. So just to make and I always strive to do this in my podcast because I always assume lowest common denominator. A lot of manufacturers I've talked to know a lot about exactly what they do, but they don't understand a lot of the terminology. So in my understanding, my simplistic understanding, you are able to 3D print very large parts on any axis, using digital files. Is that really what we're talking about?
Let's be pragmatic if you want some examples. Like we can create parts that and I apologize for my American friends if I use the meter system. It's always the,
That's all
I
good.
never know where to go. But let's say that we start from half a meter, and we go into things that are up to 10, 15 meters in the largest configurations of our robots. So this is the scale that we handle. And
Yep.
typically the robot would work on six axes, so it can print at different angles, it can print non-planar geometries, it can print hollow structure without the need of supports. So it basically unlocks the possibility of having complex geometries, large specialty parts. We're talking
Yep.
about jigs, fixtures for aerospace industry, for aircraft panel manufacturing, molds for carbon fiber lamination, as well as we're talking about parts for custom bands, campers, custom automotive applications, functional parts or spare parts, or you can
Yep.
get into printing entire boats or entire, components of a house, facade panels, what we call creative industries that are really getting this technology on crazy geometries and crazy scale.
Yeah.
So geometrical freedom and large scale parts is the two main advantages of this technology.
Yeah, that's awesome. And then kind of the on-demand portion of it too, like you can see like an aftermarket, um, you know, somebody that's making aftermarket, auto parts or panels for an old Mustang or something like that. They could just print these parts essentially when the orders come in versus having to have a stockpile of them in the warehouse.
Yeah, and I think you got it perfectly right, Nate. I think the biggest advantage at scale of this technology is that instead of actually keep on going on enlarging our factory and having economies of scale driving where we purchase our parts and maybe also making our supply chains longer and longer in order to reduce cost, we're getting into the concept of microfactory you cited at the beginning.
Yes.
So actually smaller component smaller factories, smaller shops that are basically able to have a digital inventory, so a digital amount of files that they print on demand thanks to a microcluster, a microfactory cluster that allows them with a relatively small equipment to tackle the rates of production they have without the need to purchase and have logistics for it. The
Right.
major mission we're working on and we built over time is we built more than 30 what we call manufacturing partners all over the world that are our specialized partners, that are manufacturing companies in different industries that are connected through our software and through our database, and
Yep.
which, when we receive a request for production of parts, we
Oh
basically
yeah.
direct it to the closer
Yeah.
manufacturing partner that produces on demand. And the beautiful thing about this concept is that we have partners that now are enabling global business models, international expansion without actually having to open a factory. They got in contact with the Japanese partner, a real
Yep.
example, with the Mexican partner producing the same part with the same quality only by shipping files all over and the customer getting delivered
Yep.
locally instead of
Yep.
actually getting it delivered overseas.
That's awesome. Yeah, that's it. I mean, I actually jotted that scenario down because it was kind of like when I was reading about the sort of the connectivity and the software information sharing aspect of your platform. In combination with the manufacturing capability, I was thinking about like, so you receive the PO, and then based on the connectivity, which machines have the time available to do the manufacturing, and then logistically you just decide which one makes the most sense to do it, and then you send the job over to them. The owner of that machine makes a cut of that, and then very
Yeah,
interesting.
for example, we have a matrix. We use a matrix of evaluation. Typically because we are a global brand now and people are recognizing us for this type of technology. People that have a project, they come to us. It doesn't matter if they want to buy a machine or not. Also, the particular thing about us is that for 5 years when we started, we did not actually go about saying, okay, we have a nice machine, we're going to sell it to you, like many other 3D printing examples have done. We had to create the real validation and applications for it. For 5 years, we operated as a manufacturing company ourselves. We used
Right.
ourselves, our systems. We understood how to improve it, how to make it more user friendly. So we developed it, what we say, from the perspective of the user. That allows us to understand very well what's the business model of our customer. And then when actually that distribution model came into place and the technology was ready for it, the market was ready for it, the applications were qualified, we then launched this business model in which today, when we receive a request apart, we know exactly which type of process you need, not only with printing, but also beyond that, with finishing qualifications. We have done
Yep.
qualifications with OEMs. We know
Yep.
exactly where our partners are. So who's the closest one to the actual need? And we
Yep.
map their capabilities. They might have CNC milling in house already. They might have painting booths. So we know already which type of process they can offer through our
Right.
matching system. When we get a request, that request gets matched with the closest and most relevant manufacturing partner in the area that has those capabilities to fulfill it. We basically engineer the recipe, so we guarantee quality control and repeatability of the parts across the network, and then the partner delivers locally the part by producing it and then finish it and deliver it to the customer.
Yep.
In terms of commercial engagement, that changes over time, but typically we try to be project managers because we want to guarantee the same level of repeatability and quality across the whole network.
Sure. Yep. No, it's a brilliant model, and I can see how it's also an incentive to someone to buy one of your machines because they're making that investment and they're going to have their own jobs to run on it, but you're essentially supplementing their income by giving them work from the network as well.
The way I see it, Nate, is that our job as Caracol today is to
Mhm.
make sure that large format additive manufacturing can print as many parts as possible into manufacturing needs. So that's my mission because it doesn't matter if I sell a machine or parts. In the end, if my machines are not used, I still have the same problem. So
Yep.
the way we can achieve that is by dividing and conquering. That's the way I see it. I
Hmm.
am owner of the tech. I know I can push the development of the tech, but without my end user, the real manufacturing companies that specialize the tech in the single application layers, we would move much slower. So
Hmm.
the way we see it is that we generate more value as a network rather than as a company, and that's
Right.
why we've been working on it quite a lot. So
Yep.
I totally agree with you. It helps economically everyone. At the same time, I think it accelerates adoption of the technology, meaning it increases the cake of addressable market for this technology for us, but also for our
Yep.
competition too, because it accelerates also adoption of applications. That's the most important part.
Yeah, absolutely. Yeah, that's really fascinating. So when somebody buys one of your machines, um, are there any promises that you can make to them as far as, so I guess is the idea of you getting a piece of work and then having that individual do that work in their machine's downtime, um, is that mostly theoretical right now, or is there a certain level that that person could expect of work from you versus from their own kind of lead generation?
It really depends. I don't have a direct answer on that. It depends. There are some regions, for example, where we already have significant business because as a manufacturing company, we know we have significant projects ongoing in which we really need a manufacturing partner to take that. So we actually have to outsource some of that work. And
Yep.
in some other regions in which we are discovering together, what we promise to our customers more than the actual business is the additional layers of capabilities because our manufacturing partner have access to our proprietary project data. They have access to a lot more training data, promotional materials, quoting tools. So all these things that are shared with them facilitate their business. So in these tools, they can use it to promote their own business and to actually tackle their own commercial opportunities. So the additional value that they get, as I said, is additional elements and capabilities in order to run their business and accelerate that. And then, of course, in some specific regions, it can happen that there is already a significant amount of business coming from existing projects for which we really look proactively for a manufacturing partner in that
I
region.
see. I see. Yeah, that's very cool. So, how did you get into this? Like, what was your background?
My background is business actually. I'm not an engineer, even though sometimes customers call me engineer, like, but I'm not. I'm proud that I had to learn quite a lot, and I've worked quite extensively to get there. But I was doing business first in Italy, then in the UK, and before that, I was doing strategy consulting at BCG, Boston Consulting Group. There, I specialized quite a lot into aerospace, automotive, industrial. I
Yep.
realized that PowerPoints and Excels were not for me. I wanted to get my hands dirty. And
Yeah.
so I knew these guys from university, Paolo and Giovanni, the two technical co-founders of Caracol. And together we were like, they were like, we think that additive manufacturing is the future, but it's too small. Come
Yeah.
see something we've been working on. I
Yep.
came to the lake. It was close to Lake Como, beautiful location, the first garage in which Cargo was running. I came to the lake on a Saturday on July, expecting to go to, to actually take some sun and enjoy some free time with friends. I looked at this robot. I realized that that was something I really wanted to do. So we combined the market and the technological vision. And when I was doing my MBA at Columbia University back in beginning end of 2018, beginning of 2019, we launched on the business. We did an acceleration program in the US, realized that the US was going to be the future more and more for this technology, and so created this business as we know it today by then dedicating full time on the mission, let's say.
Right. Wow. Fascinating story. One that I can relate to too. I have no background in manufacturing, no background in engineering, but I know enough to to hold a decent conversation about it. I'd like to think, and my main business.
I started like that too. Decent
Yeah.
conversation, then more and more. When you have to deal with engineers, you really need to be strong. And
Right.
so I did a lot of training on the job, let's say.
Yes. Yeah. Same here. Yeah, my main business is we create a marketing agency, and over the years we worked more and more with manufacturers, and I just really enjoyed working with them. I love learning about the processes and what they do, and at this point, I talk to a manufacturer, and they're shocked at how much I understand about materials and about the processes and stuff like that. So it's fun. It's fun when you can match these really really smart people, in their own specialty. So, so tell me a little bit about some of the use cases. You mentioned aerospace, automotive. Uh, is there, I guess, a typical type of business that buys one of your machines and incorporates it into their own offerings?
I think couple of use cases. There is we call them verticals basically. So you have the vertical, the more like the creative vertical that I was mentioning. That is what invented the technology. That what you can imagine parts for amusement parks, entertainment, stages, parts for construction, hotellerie, hospitality, wall panels, furniture, retail stores, specialty stores. All that is basically the value proposition is these are manufacturing companies that they have been using traditional manufacturing techniques to serve this type of needs, one-off projects, custom ones, done at a significant scale, architectural scale, in which the value proposition of this technology is basically geometrical freedom, scale, and
Mm-hmm.
recycled material, because it can be fed with recycled material and it can actually push also sustainability. That becomes more and more important. We're talking about, as I said, fashion, construction, and architectural firms being one main segment. The getting more into the industrial side, the core segment of what we do is what we define as transportation. So you have custom automotive being one, as I was saying. So custom parts shops, custom vehicles OEMs, specialty vehicles OEMs, for which the complexity of the shape and the scale, we're talking about light commercial vehicle, we're not talking about passenger cars in this case,
Right.
makes it interesting because also the volumes don't justify molds and make it much more
Right.
flexible in terms of business model for them and customizations. Every single piece is slightly different from the other. And
Right.
then we move into maritime, where we are talking about luxury yachts, transportation of passengers, cruise ships, ferries, in which
Yep.
you're talking about very, very big projects with high level of customization, high requirements, but in which this technology really gives the best because these are very high complex parts, very long lead times, and you can
Yep.
produce on demand thanks to this technology. And last but not least, entire boats. So you get to the boat whole project. And right now, drones, maritime drones, are becoming more and more important. USVs, unmanned surface vessels, in which this technology is being qualified as we speak and is becoming more and more relevant to enable fast deployment and distributed manufacturing directly on site. So that becomes a big asset because you can control it digitally and ship actually the manufacturing technology rather than shipping the part and producing on the ground directly. So these are the verticals, and typically the companies we work with are either OEMs that qualify the process. They get in house the first machines to study the process and certify the full development of this technology, and then there are tier one and tier two suppliers that they become the major supplier of parts with these new manufacturing techniques. So typically, this is the type of industries and companies we work with.
Very interesting. Yeah. Okay. Yeah, and yeah, that all makes sense. So it would be kind of like lower volume, very complex, very large parts that you don't set up an entire manufacturing facility to do this project because that's way too much investment. So you can have this machine that'll just print them on demand when you need them.
And imagine, the big example now, there is a booming composite industry. Why? Because lightweight performance, space is an example,
Yep.
new maritime industries, new primes that are happening all over the US, for example, also in Europe. These companies need fast deployment. They need to be fast. They cannot wait, for a full manufacturing line. They are iterating and changing their product over time, and they need to produce everywhere in the world with a small footprint, but fast enough. And so this technology becomes more and more relevant because what we are used to think as small series in the traditional manufacturing methods, let's say automotive, now is being reshaped and completely disrupted by these new geopolitical dynamics, for which reshoring is actually making these companies more and more relevant for the industrial footprint, and they have a strong need to fulfill that growth faster and with a more
Yep.
flexible manufacturing structure. This technology allows them to do that. It can be deployed, it can be scaled up, it's modular, it can print on demand with little to no inventory, high level of possibility to customize. This makes them much more flexible to react to the market changes too.
Yep. So when you're in a sales process with an OEM, what are some capabilities of this technology that surprise them that maybe they didn't know about? Maybe it could be like the materials that you can print or, whatever.
I think speed. The first thing they're surprised of is speed because with 3D printing, many of those know 3D printing and they know that it's too slow sometimes compared to injection molding you mentioned on a smaller size. What we have been developing is, for example, in the polymer side, is based on pellets, not on filament. The deposition rates are again for the metric system or like European system, kgs per hour, 10 kgs per hour, 10 kilograms per hour. So a lot of material is poured in. The printing times are much slower, much shorter than they thought. They're surprised by speed, and in some cases they are surprised by also the geometrical freedom, the scale at which you can build these parts, and how complex these parts can be. Typical geometries. I'll give you an example of a public case. Ferretti Group, with their brands Pershing, Riva, the best of luxury yachts in Europe and beyond. They have these lateral air grids for their biggest yachts of the Pershing lines, in which imagine an air grid that it's very hard to make the mold for, like a geometry that for them
Yep.
is super complex to do, and they need to do 10 a year. So really, it's a nightmare to get that mold done, super expensive, and
Yep.
every single air grid though is worth it for more than 50,000. So it's high value part for them. It's critical. With our geometry, it's very simple. It becomes super simple. So the shock for the customer sometimes is really okay. It's a new technology, so I need to go step by step. I need to make sure it works. It fulfills my criteria, my prerequisites. But at the same time, they are when they get the right business case, they are completely amazed by speed and also the level of complexity of parts they can achieve thanks to the technology.
Yeah, that makes a lot of sense. So you said it uses pellets, not filament?
Yeah, on the polymeric side, we have two major, technologies. We started from pellets, composites, polymers, and composites.
Yep.
So it uses thermoplastic composite compounds, pellet
Yep.
based, much cheaper. The material is 1/5, 1/10 of the cost compared to filament, and faster deposition rates. And the metal side is called Hero AM, our platform. And then the metal side, we have a similar robotic platform that we have launched on the metal side for as a wide arc additive manufacturing process. Typically, an evolution of a welding process. Let's say a 3D welding process. If for those that are not super familiar for it, that is wire fed, And
Yep.
there as well is much faster compared, for example, to powder bed fusion. That is another additive manufacturing technology very used in defense, in aerospace, for higher precision parts. So productivity is typically for both the machines one of the major assets.
Okay. Yeah. Yes, and so that's called what? Electric deposition. What?
The DED is the the definition is called direct energy deposition
Energy
technology.
deposition. Okay.
Yeah,
Yeah.
it's
Gotcha.
basically is a welding torch that applies some energy directly on the metal, and with a wire that is being welded with the wire with the part, layer
Gotcha.
on layer. It gets you the shape of the part.
Gotcha. Yeah, that's fascinating to me. That's a really, really cool process. What kind of stuff can you do with the DED?
Perfect. Yeah, we can do propellers for boats, spare parts. You can do repair on existing parts. You can do pressure vessels for spacecrafts or
Wow.
launchers. You can do valves, gouges for the oil and gas and energy industry. You can do repair and spare parts for vehicles.
Yep.
I cannot share much, but we're working with some of the governmental forces in order to qualify this technology on land and sea vehicle. So spare parts is a big one. You can do components for a ship, very, very large ship where everything is already welded today. When
Yeah.
you're putting together a cruise ship, you have an army of people with a manual welding. They're welding parts all over the ship.
Yep.
Imagine if you can already manufacture these components by reducing the manual welding of the operators. Today, one of the major problems is that they don't find welders, and so
Right.
all that it becomes more and more interesting for them.
That is very interesting. Wow. Yeah, that opens up unlimited possibilities. Where where do you feel the biggest lack in knowledge is? Whenever you bring a new technology to market, it's very typical to feel frustrated that I wish people got this. I wish people understood it. Like, what message would you send out into whom?
I think the first thing is mindset. The problem of some of these industries that they are very manual still. So there is a
Mm-hmm.
lot of these companies are run by few very big experts of their process. They've been doing this for years.
Right.
So the biggest message to them is that don't be afraid. You are not becoming less relevant. We're giving you a tool to make your job better, faster, and you'll be crucial anyways because the biggest lack of, I think, competence is still, and that's our job too, is in training them in understanding on how to use the machine as a complementary asset to what they have already. We're not substituting people. We are refocusing people's time on something that is along the process because the finishing in some cases needs to be done exactly the same, and they can focus more on programming the machine rather than applying by hand some of the material on it. So we're also requalifying some of those operators in making more higher level jobs or making more machine interaction jobs rather than manual work on the part itself. So the first
Right.
message is for them, for the people that run the shops. This technology helps you. It helps you build faster and it helps you do things that are tough to do today manually. Of course, it's still it is being adopted, but it's still an early and young technology. It's only 10 years old. So we created the market together
Yep.
with a couple of other companies. So we need you to keep on evolving that. We need you to engage with it. We need you to letting us understand what we can improve to make your life easy to adopt it. Because as of today, there's still a barrier in which we need to train extensively some of these operators to fully leverage the capabilities of the machine. It's improving every minute that we speak. At the same time is the biggest challenge, and I think the biggest obstacle that together with our end users we're trying to overcome.
Right. Okay. Yeah, all that makes sense. Um, so, what is sort of the training? What's the workup time? What is kind of like to achieve like a base level of understanding of the machinery to be able to utilize it? Like, what does that take?
We do an installation time that is like 3 days and then 2 days of full training, operator training, in which we train them on how to run the machine. Of course, together with that, there is also how to design for the machine, how to program, how to use our software. So typically what we do is that You have 2 days full-time training in which you have a really basic understanding, and then you build on top of it. I would say that if you are already skilled in using some machineries, it can be CAD/CAM for CNC, or it can be other robotic platforms. Our interface and the way we have built, for example, all the software is to make it as user-friendly as possible. You don't need specific robotic skills to run our machine, but you need to understand the logic of how to program for this type of process and this type of machine. So I would say 2 to 5 days, it's a enough training to have to run. And then you need to build your experience layer. The more you run projects, the more you see different geometries, the more you understand and run materials, the more you build different approaches that allow you to be more productive, to increase your ROI. So the basic training gets you to use it and utilize the machine and deliver what you were supposed to. Then the experience gets you, and we say that typically the real ramp up time is where we try to be as close as possible to our customers, is the first 6 months that they use this machine, because they start from understanding to operating to optimizing more and more step by step their learning curve and also their economics in running the machine. And
Right.
that's why, for example, in Caracol, we decided to go not as many European companies do. We're going to open our US entity that is going to be full of commercial people. No, our US entity is a manufacturing shop with service engineers that are close to our end users, that
Okay.
work side by side with our customers, that they reply within 24 hours and they run jobs together with you. Support is our first lever. And why? Because on the one hand, we are the user. We still run our machines. We have those 5 years of experience. We still do that. We still run that manufacturing central hub in Italy to still be up to date of which are the major challenges and the major things that we can unlock for our network. And by doing that, we also have an advantage level of service we give to our customers, because I'm going to help you service your machine from the user perspective. I'm going to help you on your parts rather than on running your machine. You will be
Yep.
running your machine thanks to my advice, but I focus on your project first, and then together we will run the process. I think that's a big of value added.
Oh, big time.
It's expensive. It's an investment. It's not
Yep.
easy to run globally, but that's the core of our mission. We want
Yep.
to enable the production of parts. How? Through very good technology, good support, and new investment in unlocking new applications.
Yep. No, that's huge. That's such a big value add to actually have the assistance on the ground. Uh, would you say that the baseline level of qualification, like if somebody was going to buy this machine, they should probably have CNC programming experience? What do you need from
It really
somebody?
depends, Nate, because I've seen customers buying this as a first equipment in their life and being very successful to it because they had a clean, white page.
Okay.
We are strong on training because, as I said, if you're a first user, you give tips and tricks that go beyond how to use the machine.
Yep.
So some cases it really like having a basic understanding. Maybe I would say there are three categories of users: the ones that have been using 3D printing before, and so they jump into this. They understand the logic of how a slicing software works, a machine works, but they need to understand that this is way more flexible than a normal printer because it has 3 axes more, for example. It has the possibility to be larger. So they need to, they are a bit stuck into traditional 3D printing and they don't understand fully the advantages and limitations of this, but they start from a good base. Then there is a second, and it's good. It's good enough because we can train them through experience. We show them, and they build the gap that they have. There
Yep.
is the ideal users. I think they have had already CAD/CAM experiences with other type of tools, and that's pretty interesting because they know robotics in some cases, or they know how to program a 5 axis gantry. That gives them the understanding of how I need to program for a machine, that I need to set up a machine, that I need to manage post processing on a part. So they have manufacturing capability, or even I would say a completely green operator that, however, is keen to learn and knows the basics of manufacturing, as a logic. I've seen that in the past. We can build from there. It would take a bit more at the beginning, but then it's probably going to be a much more verticalized and specialized operator because that's the main experience he has been training on.
I see. Okay. So do you see people completely building a business around this one machine?
This is the thing I'm the proudest of. There are two things that drives me at work. One is
Yeah.
seeing my employees and my partners growing and taking on new challenges. And we're all very young in the company, and you learn fast. There's a lot of responsibility, but you grow a lot. But the second, the most important one that we're proud of, we see complete spin-offs of existing companies starting with 12 machines in it, equipped by us, or companies and entrepreneurs that they get to meet us. They had a business idea, producing a chair or like a line of products and e-commerce globally, and they buy as a first manufacturing technology hours, and they start a business from scratch. I've seen that happening in Mexico, in Japan, in the US, in Italy. And this is the thing that makes me the proudest of, because it means that we're creating value. In the end, I don't care how many machines we sell. If there are people that are making good money and new opportunities thanks to these machines and thanks to our support, it means that there is value for it. Otherwise, they would be maybe buying a couple of machines here and there, but that would stop. And many of our customers are scaling fleets, and this is probably the thing that I've always wanted to see. And more, I think it's going to measure how good we are doing in terms of supporting our customers.
Right. Yeah, well, that's really cool. It's kind of like, I'm thinking like marketing track right now, but if you have 10, 15, 20 of those use cases where somebody built a business completely around the machine, that's such a great way to build an understanding of what they're capable of. And then you have somebody new coming in that says, hey, I want to build this, this custom gaming chair and build a business around that. How do you manufacture a custom gaming chair? Well, guess what? Caracol has a case study on their website about building a gaming chair with their machine. And they're like, oh, so I don't need to get, overseas manufacturing and have 50 different suppliers. I can buy this one machine and build my entire product.
And I can work with a manufacturing before. So I have a local manufacturing partner in New Jersey, just saying a state where we have a very strong partner that started from scratch, and thanks to our machine now is scaling. Just installed the second and scaling with the third. I want to mention them because I think they deserve this visibility. It's called Decibel Made. Great guys, young guys from that started their business with normal 3D printing, but that they really took off thanks to large format, thanks to their vision. You can work with them, do the pre-phase of your business together with them. They help you in the development. You don't need to buy overseas. Get your product ready, and when your product is ready, maybe you can also scale your fleet and maybe have a specific manufacturing needs with this machine to actually fulfill that. Everything in the USA with local people, with a local ecosystem, with a local support of companies that are investing locally and helping you every step of the way. That's the way we want to build our ecosystem. We talk about community and ecosystem. I love it. This is the way we want to work everywhere we go. It doesn't matter if we started from Italy. Wherever we get into a country, we need to create a community and an ecosystem. We need a manufacturing partner. We need local support. We need an ecosystem, a technological ecosystem that helps the customer runs and tackle all the challenges of producing these products.
Amazing. Well, very cool. I really enjoyed our conversation. It's fascinating to learn about this new technology, and I completely agree with you that additive manufacturing is the future of manufacturing. And the microfactory concept is just super vital to sort of the U.S. goals of reshoring, because you're not going to be able to start up, hundreds and hundreds of new types of factories here, but having the ability to do these things on a small scale, I think could solve a lot of those issues. Plus the workforce issues. I mean, that's another big value.
Workforce issues and time. The world is moving faster and faster. Supply chains are changing faster and faster. How can you be competitive over time? You need to be flexible. You need to react fast. You need to deploy fast factories. And I think what's happening on defense right now explains that very well. We need to build manufacturing capabilities in times that are a fraction of what we used to in the past. How do we do it? New manufacturing techniques. And that's what we try to address.
Awesome. Well, Francesco, I really enjoyed it today. Thanks a lot for joining all the way from Italy. Hopefully I can come visit you soon over there. Never been to Italy. I'd love to.
We give you a good excuse. Thank you for inviting me, Nate. It was great to chat to you.
Awesome. All right. Thank you.